Have you ever stood on a train platform watching a giant locomotive pull in? The anticipation builds as you hear the distant whistle, and you can almost feel the vibrations in the air as it gets closer. It's a sight to behold. The sheer size and power of these machines are awe-inspiring. The ground rumbles, the air fills with anticipation, and then, with a mighty roar or a quiet hum, the train comes to a stop. The steam hisses and the brakes screech, creating a symphony of mechanical sounds. But have you ever wondered what makes these iron horses run? What kind of engineering marvels lie beneath their robust exteriors? Today we're going on a journey to uncover the magic of rail engines. From the earliest steam engines to the latest high-speed trains, we'll explore their evolution. We'll explore the powerful engines, the clever mechanisms, and the dedicated people that make train travel possible. These engineers and mechanics work tirelessly to ensure every journey is smooth and safe. Get ready for an exciting ride as we delve into the fascinating world of locomotives. We'll see how technology has transformed these machines over the years. Fasten your seatbelts, and let's get started. Whether you're a train enthusiast or just curious, there's something here for everyone. We're about to embark on an adventure to understand the science and engineering behind these marvels of transportation. From the drawing board to the tracks, every detail is meticulously planned and executed. Get ready to be amazed. The world of trains is full of surprises and incredible feats of engineering. So, all aboard for an unforgettable journey. Every train needs a heart, a source of power that propels it forward. This heart is called the prime mover. Think of it like the engine in your car, but much, much bigger. The prime mover generates the energy needed to turn the wheels and move the train. But how does it do that? Well, there are different types of prime movers, each with its own unique way of converting energy into motion. Let's explore these fascinating engines. First up, we have the diesel engine. These powerful machines have been a staple in the railway industry for decades. These workhorses are like giant diesel trucks, but on rails. They are known for their robustness and ability to haul heavy loads over long distances. They burn fuel to create hot gases, which push pistons that turn a crankshaft. This process is similar to how a car engine works, but on a much larger scale. This crankshaft is connected to the wheels, making them turn and propelling the train forward. Diesel engines are particularly valued for their reliability and efficiency. Next, we have electric engines. These are often seen in urban and high-speed rail networks. They get their power from electricity, either from overhead lines or a third rail. This method of power delivery allows for a cleaner and quieter operation compared to diesel engines. Think of them like giant toy trains, but instead of batteries, they use a much more powerful electric current to spin their motors. This makes them incredibly efficient and capable of high speeds. These motors then turn the wheels, making the train move. Electric trains are often preferred in densely populated areas due to their lower emissions and noise levels. And finally, we have the granddaddy of them all, the steam engine. These iconic machines are a symbol of the Industrial Revolution and the early days of rail travel. These magnificent machines use the power of steam to drive their pistons. The process involves burning coal or wood to heat water in a boiler. Water is heated in a boiler until it turns into high-pressure steam. This steam is then directed into cylinders where it pushes pistons back and forth. This steam pushes pistons which are connected to the wheels, making them rotate and driving the train. Steam engines, though largely obsolete today, are still celebrated for their engineering marvel and historical significance. Each type of engine has its pros and cons, but they all share the same goal to move the train. Whether it's the reliability of diesel, the efficiency of electric, or the nostalgic charm of steam, each plays a crucial role in the history and future of rail transport. Section 4, From Wheels to Rails, the Science of Motion. Now that we know how the engine creates power, let's talk about how that power actually moves the train. The engine's power is transferred to the wheels, but it's the interaction between the wheels and the rails that truly propels the train forward. The answer lies in the wheels and rails. This interaction is a marvel of engineering designed to maximize efficiency and safety. Train wheels aren't just round, they have a slightly conical shape which is wider on the outside. This conical design is not arbitrary. It plays a vital role in the train's stability and direction. This unique shape is crucial for keeping the train on track. The conical wheels help distribute the weight evenly and ensure that the train remains centered on the rails. When the train leans to one side, the wider part of the wheel on that side contacts the rail, guiding the train back to the center. This self-correcting mechanism is essential for maintaining balance, especially on curves and uneven tracks. It's a simple but ingenious system that ensures smooth and safe travel. The conical wheels and the precise engineering of the rails work together to provide a seamless journey, making train travel one of the most reliable modes of transportation. Section 5. Linking up. How train cars stick together. Have you ever wondered how all those train cars stay connected? The answer is couplers. These sturdy metal devices link the cars together, allowing them to move as one unit. Couplers have a special mechanism that locks them in place, preventing the cars from coming apart. They also absorb shocks and bumps during the journey, ensuring a smoother ride for passengers and cargo alike. Section 6. The conductor's domain, steering the iron horse. At the front of the train we have the control cabin, the conductor's domain. This is where the magic happens. The conductor is responsible for operating the train, controlling its speed, and ensuring a safe journey. Think of the conductor as the captain of the ship, guiding the train along its designated route. They communicate with other crew members, monitor the track ahead, and make decisions to keep everyone safe.